Hello and welcome. Today, we're diving deep, I mean microscopically deep, to solve a mystery that's probably happening in your kitchen right now.
Yeah, we're talking about water. You've got solid ice, liquid water, and then gas or steam. It's all the exact same stuff, H2O, but they act completely differently. So how is that even possible? Well, to get the answer, you gotta change your perspective, like way, way down.
All right, get ready for this. For the next few minutes, you're not you anymore. Nope, you are a single tiny particle. Your whole mission is to experience what it's like to be a solid, a liquid, and a gas. And by the end, you'll have a really simple way to understand how it all works. So let's get started. Okay, our story begins right here, in the super organized, kind of rigid world of a solid. So picture this. You're one particle inside a giant block of ice. What is life like for you in there? Well, for starters, it is crowded. You are locked in, like shoulder to shoulder with all the other particles around you. There are these incredibly strong forces. Think of them like invisible little bungee cords, holding you all together in this perfect tight pattern. You can't just wander off. You can't even slide past your neighbors. All you can really do is jiggle. You just vibrate right there in your spot. It's a life that's super structured, super orderly. You're part of this huge, rigid team. But what happens when things start to heat up a little? And this is where the real adventure kicks off. An outside force is about to pump you full of energy, the energy you need to finally break free. And that force, my friends, is heat. So what even is heating? It's really just energy being transferred directly to you, the particle, kind of like someone hands you a super caffeinated energy drink. And once you get that energy, you start to change. So as that heat energy just floods in, that gentle little jiggle you were doing, it turns into a wild, frantic vibration. You're shaking so violently that those bungee cords, the forces holding you still, they just can't take it anymore. Snap! And just like that, you're free from your fixed spot. You can actually start to move, tumbling and sliding all over your neighbors. We call this, of course, melting. And welcome to the liquid life. The forces holding you are way weaker now, but they haven't vanished. They're still just strong enough to keep you and your neighbors all touching, flowing together in a group. But your escape isn't over yet. There's more energy coming your way. As even more heat gets pumped into you, you start zipping around faster and faster and faster until you've got so much energy that you completely overpower those last few weak forces holding you to your friends. You just break away and launch yourself into the open air. You're out of there. You've just evaporated. And you can really see the difference here, right? As a liquid, you were part of a crowd. You could move around, but you were still connected. Now, as a gas, you are a solo agent. There are literally no forces holding you back. You are totally free to fly anywhere and spread out as much as you want. But, every journey has a return trip. Let's just flip this whole process on its head. What happens when your energy starts to get taken away? Well, it's time for the big chill. Cooling is the total opposite of heating. Instead of gaining energy, you are now giving your energy away. You're transferring it to the colder things around you. Your high-speed adventure is about to slow way down. So imagine you're a gas particle. You're flying free and then, bam, you smack right into a cold surface, like the outside of a chili glass. Instantly, a big chunk of your energy gets transferred to that surface. You slow down, and as you slow down, other slow-moving particles start to glom onto you. You're clumping together, forming a little liquid drop. That is condensation. Yeah, that awesome freedom you had as a gas? It's pretty much over. Those weak forces of attraction are grabbing hold again, pulling you back together with all the other particles. As the cooling keeps going, you lose more and more of your energy. Your sliding motion slows down to a crawl, and then to nothing. You have so little energy left, you can't get past your neighbors at all. And that's when the strong forces take over again, locking you back into that rigid, perfect pattern. All you can do is vibrate. You have frozen. Your journey is complete, and you're a solid once more. So now that you have literally lived the life of a particle, from solid to gas and back again, let's turn this whole experience into a simple formula you can use to explain any of these changes. Believe it or not, it all comes down to just one number: 3. 3 simple steps. Anytime you need to explain why matter's changing, just think about these 3 things.
Okay, first, describe the particles where they are right now. Are they locked in place? Are they sliding around? That's step one, your starting state. Second, what's the trigger for the change? Are we adding energy by heating or taking it away by cooling? And third, describe what happens next. How do the particles act in their new state because of that energy change?
Let's test it out with evaporation. Step 1, in a liquid, particles are close, they're sliding past each other. Step 2, we apply heat. Simple. And step 3, because of that heat, the particles gain energy, they move way faster, and they break those weak forces to fly off as a gas. See? Simple. This formula works every single time, for any change of state. Okay, you can stop being a particle now. Your journey is over, but your new understanding of the world is really just beginning. Let's zoom back out. Here's the really cool thing. What you just went through, it's not just a story about water. This fundamental journey of particles gaining and losing energy, of vibrating and sliding and breaking free, that is the secret story of almost everything. It's why metal melts, it's why a candle burns, it's why dew forms on the grass in the morning. So from now on, whenever you see something change state, remember your journey. Think about those little tiny particles. What's really happening to a chocolate bar that's melting in the sun? Now you've actually got the tools to figure it out.